You should also be able to find tangent lines when you have to read either from a graph or a table, so that's our next section. F prime, the derivative of the function f, is graphed below. This is f prime. If f of 1 equals 2, write the equation of the line tangent to f of x at x equals 1. So the first thing is that we know we have our usual equation for tangent line. So we need to know a point, an xy point, and we need to know the slope. So the key thing here is that this is a graph of f prime. It's not telling us anything about y and x of f. But we are told, because f of 1 equals 2, that means we have the point (1, 2). So that's our x and our y. Now we just need to find our slope. We know that the slope, we're going to be at x equals 1. So that's f prime of 1. This is where the graph comes in handy. We just have to know what we're looking at. F prime of 1 is this point right here that I labeled it because that's the only important one. It equals -1. So that means that all of this just goes right in here. Y minus 2 equals -1, x minus 1. There we go. Sometimes we have a graph or a table for f, and we then have to go and figure out something about f prime. So the table below gives values of x and f of x. Estimate f prime of 4. So first let's turn this into a sketch of a graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'll do just a little rough sketch. There's 1, 0, 2, 3, 4, 5, 6, 9, 8, 12, 10, 15. Right about like that. Now, we have no idea what this actually looks like. It could be some, completely, radical, weirdo, sort of funky curve like that. Well, actually, that wouldn't be a function, but almost like that. Or it could go in some completely other different direction. We really don't know. But our best estimate of the slope of the tangent line at x equals 4 itself is going to be the slope of the secant line between the two nearest points. Basically what we're looking at is we don't know exactly how this curve is going, but it's probably, our best guess, going to be having a positive slope because the function overall seems to be increasing, and maybe it's the case that it actually goes up here and then sharply down here and then back up like that. Maybe it does, maybe it doesn't. There's no way for us to tell. So our best estimate is the slope of the secant line Remember, secant line is just a line between 2 points instead of tangent to 1. So our tangent line right there, our best estimate, this line right here, going from the point 2, 3, the point 6, 9. So that's change in y, 9 minus 3, over change in x, 6 minus 2, (1.5), right, like that. Some sort of estimating the slope of a tangent line from a table shows up really frequently in applications for real-world problems. So you should be familiar just with the idea that if you're trying to estimate the derivative of a function and all you have is a table, you're going to be looking at the slope between the two lines on either side of, between the 2 points on either side of the point that you're interested in.